welcome back to the 6th episode of SPSS MasterClass for Beginners. Here we are breaking down the statistical analysis software known as SPSS. So in the last video, we discussed as to how can we calculate the OneSample Z-test in SPSS. Now we are going to look at the process of doing a OneSample T-test. So without further ado, let's jump into the 6th episode of SPSS MasterClass for Beginners. Hey guys, my name is Shardul, hailing from ShaVash tutorials and creator of ShaVash.co.in. I am also a junior research fellow at the Indian Institute of Information Technology, Allahabad. Before we begin the masterclass, if you are interested in any tech product, software or language, be it for coding or research purposes, then be sure to subscribe by clicking the red subscribe button on this channel and also the bell icon next to it so that you never miss an update. Also, there's a complete playlist of the masterclass in the description so that you can go to the other videos when you're done with this one. Just click on the link and it will take you to the complete playlist. So we are going to go to our data that we have been using in our previous videos, which you can download from the link in the description below. We see that our data has 13 participants and we have corresponding heights of all these participants. The heights have been measured in centimeters. We actually use a OneSample T-test in a very specific situation. We do it when we have to compare the sample means with a known population mean. But specifically, we use it when we don't know the population variance. If we did know the population variance, we would use a OneSample Z-test. Similarly, we do a OneSample T-test when the population mean is known but the standard deviation is unknown. When we know the mean and standard deviation of the population, we perform a OneSample Z-test. In order to perform a OneSample Z-test in SPSS, check out my previous video from the description. So in this video, we will be performing our test on the height variable. Here we are interested in testing the hypothesis that this group of people have a height mean value that is greater than the population. And let's say we can find that in the population height, the average or the mean of the population height is 155 centimeters. So now the question is, that is our group of 13 participants from whatever population they are they different from the normal population which has a population mean of 155? So let's begin. To do this, let's first refresh our memory as to what the sample mean height is. We have done that in our previous videos, so check them out if you like, but we're just going to look at it to see what it actually is. We'll go to Analyze, then Descriptive Statistics, and then Frequencies. We'll move the height to the test variables and then go to Statistics. We'll select Mean and click Continue. Deselect the Display Frequency Tables and click OK. So our sample mean over here is 168.1 centimeters based out of 10 samples. So the hypothesis is that 168.1 mean value will be different than the 155. So in order to do this, all we're going to do is we're going to go to the data menu. We'll go to Analyze, then Compare Means, and then OneSample T-test. This will bring up a window. The left window will, like always, have all of our variables. Then we'll have a test variable side on the right and a test value at the bottom. We're going to move height to the test variable side because we are interested in comparing the average of this sample to the population mean height value. That population mean value, we're going to put it in the test value box. In this case, we want to compare our sample mean to the population mean of 155 centimeters. So we're going to put 155 in the test value box, and then all we're going to do is click OK. Now we can see that two tables have appeared. The first table is the OneSample statistic that is measuring for height as the dependent variable. The N is the number of people who have participated in the study, the population size. It has the mean of the sample along with the standard deviation and the standard error of the mean. Then we go down to the second table, which is OneSample TTest. We see that the variable we are comparing is the height of the participants, and then in the first three columns we have the values that we're going to need. The first is our T observed, in this case is 3.48435, our degrees of freedom, which is n-1, which equals 9, and our significance value, that is p value, as 0.007. 007. Nice. Now if our p value is less than 0.05, we reject the null hypothesis. So in this case, the null hypothesis is that our sample is exactly like the population and there is no statistically significant difference. We would thus have to conclude that our sample is not like the population. Our mean will also show that there are longer people in our sample than the population. Now suppose that our population mean is not 155 centimeter but 165 centimeters. What would happen then? Well, we can run the same analysis again. We go to the data window. We go to Analyze, Compare Means, OneSample TTest. Let's change our test value to 165 because that's what we are checking. Then we click OK. We're gonna see that the sample mean is the same, but all of a sudden our significance value has shot up drastically. This is because 165 is much closer to a sample mean of 168.1. In fact, the difference is only 3.1 centimeters, and therefore it is no longer significant. We would say that our sample height is just like the population height. So yeah, that's how it's done. So that right there is how you calculate the OneSample TTest in SPSS. In the next video, we will explore how to do a correlation in SPSS. If you enjoyed it, make sure to subscribe and hit the bell icon so that you do not miss the next video of the SPSS Masterclass series. So thank you for watching, and I'll see you in the next episode of the Masterclass series.